What happens when we perform a linear transformation on a variable? Let's recall some things from algebra. The line y equals x is a straight line. And we could make ourselves a little t-chart here where we would put 1, 2, 3, and 4 in for x. And since y and x are equal, the y values would be the same, 1, 2, 3, and 4. And we're very familiar with this diagonal line that this particular relationship makes. Passes through the origin, slope of 1. M is 1. Here, if we were to multiply all the x values by 2 in order to find our y values, then we can put these same values in for x that we did before, but the y values now are going to be more spread out. There's going to be some distance between them. And if I graph that line, that phenomenon of the y values being more spread out, we can see here in that the line is steeper. We cover more ground in the range for each of those incremental units of the domain. Actually, this line has a slope of 2. But the point is that we still have a straight line. So by doing what we did, multiplying by 2, we haven't changed that fact. We still have a straight line. Now let's do something else. Let's take that y equals 2x, and then let's add 2 to that. So we can again make ourselves a little t-chart here. Put those same x values in here. And now for y, we're going to have 4, 6, 8, and 10. Now something that we'll notice here is that each of the y values is larger now. We have larger y values, but the difference between them has not changed. The difference between each of these y values here is 2. And the difference between each of these y values is 2. And what does that do to the graph? Well, it doesn't do anything more than just shift it up 2 units. And we know that because we're in this y equals mx plus b form that we're used to from algebra. And where our slope is 2 and our y-intercept is 2, it just means we're taking this line right here and shifting it up 2 units. So we're going to have the dot 1, 4 rather than 1, 2, and then the dot 2, 6, and on up like this. So this graph is going to have the same slope as the previous graph. It's just shifted up 2 units. And again, the thing that's interesting to us about that is that the distance between the values here is not different. It's still 2. It is different here. The difference between these y values is 1. So when we do this with a data set, it's going to have an effect on the mean and the standard deviation. But the question we want to answer is, what effect do linear transformations have on the mean and standard deviation for a data set? In the next video, we will look at the effect that linear transformations have on the mean and standard deviation of a variable.